Alright, in this video we're going to talk about finding the x-intercepts of a quadratic function. So remember, x-intercepts are where it crosses the x-axis. In general, quadratic functions have a u-shape, either a u going up or a u going down. In this case, this particular function here is an upward facing u. And where it crosses the x-axis is going to be as such in this little picture here. And x-intercepts, for any x-intercept, whether it's a quadratic function, a linear function, a radical function, the x-intercepts are where y equals 0, right? So y is the vertical axis. All the numbers going up are positive, getting bigger. All the numbers going down are getting negative. And right there at the origin, or at the x-axis, the value of y is 0. So to find an x-intercept, we have to let y equal 0. When it's in a function notation, that means when f of x equals 0. So we have to solve the equation 0 equals x squared plus 3x minus 7. So for any function, finding the x-intercepts is when y equals 0. So we're going to replace f of x with 0 and solve it from there. So now we can find those x values. So replace y with 0, solve for x. If we look at this quadratic equation, again we should start by trying to factor. But the only factors of 7 are 1 and 7, and we'll never get them to add up to 3. So it's not factorable. If it's not factorable, to solve this, we either have to complete the square or use the quadratic formula. I'm going to go ahead and use the quadratic formula here. So identifying a is 1, b equals 3, and c equals negative 7. I'm going to plug this into my formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Alright, simplify what's under the radical. We have 3 squared, which is 9, and negative 4 times 1 is negative 4. Negative 4 times negative 7 is a positive 28. So we'll have 9 plus 28, which will give us 37 underneath the radical, and 2 times 1 is 2. Now it says to approximate to the nearest thousandth. Alright, so we have to plug this into our calculator to round it to the nearest thousandths. And I have two solutions. So I'm going to type in plus that square root of 37, all divided by 2, and negative 3 minus. So I have to make sure I do both when I type it into my calculator. Alright, let's go ahead and pull up a calculator here so you can see it. Alright, I'm going to go ahead and start with the radical because this is a computer calculator. It's easier that way. So 37, and take the square root of that, and I'm going to add 3 that is negative. So that's the numerator. Negative 3 plus that square root of 37. Divide it by 2, and I get 1.5413 blah blah blah. We have to go out to the thousandths place. So tenths, hundredths, thousandths. We look to the right. That 3 says leave the 1 alone and drop everything else off. So x will be approximately 1.541. Now we do it with our other solution. I have 37 again. I'm going to take the square root. Then I'm going to make it negative because this is the negative solution. I'm going to add a negative 3 to that, and then divide by 2. So for this one, again, I got tenths, hundredths, thousandths. The 3 says leave the 1 alone. So I'm going to end up with a negative 4.541. And those are our two solutions, approximately out to the thousandths place. Go ahead and try the example on the right. It's the same starting idea. You're going to set it equal to 0, but you don't want to plug in fractions into this formula. So I would recommend clearing the fractions first and then identifying your A, B, and C. Alright, here on the right, find the x-intercepts of the function g of x equals 1/6 x squared minus 1/2 x minus 1. To find x-intercepts, we have to let y equal 0. So in this case, we're going to let g of x equal 0 and solve for x. Now, I do not want to deal with these fractions. I don't want to put that into my quadratic formula. So we're going to clear out the fractions by multiplying by the LCD. The LCD, looking at these denominators, 6 and 2 would be 6. We multiply both sides of the equation by 6. 6 times 0 is still 0. 6 times 1/6 is 1, right? 6 divided by 6 would be 1. I'm left with just 1x squared. 6 times 1/2 would be 3, so minus 3x. And 6 times negative 1 is negative 6. So now my A is 1, B is negative 3, and C is negative 6. And that's what I'm going to plug into my quadratic formula. Negative b, so negative 3 would be positive 3, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And we simplify what's under the radical. I have negative 3 times negative 3 will be 9. Negative 4 times 1 times negative 6 is a positive 24. So we'll have 9 plus 24, which will give me 33 under my radical. That can't be simplified. It's just 3 times 11. There's no perfect squares. And it will all be over 2. So now I have to find my two solutions. So I have to make sure I plug them into my calculator properly, because it says to round to the nearest thousandth. I'm going to start with my radical. So 33, take the square root. Then this is the positive, so I'm going to add 3 to that, because there's a positive 3 here. And then divide by 2. I'm going to take it out to the thousandths. So tenths, hundredths, thousandths. That 2 on the right says leave this 2 alone. Drop everything else off. So I'll have 4.372. Now I need to do my negative solution. So now again, 33, take the square root of it. And then I need to make it negative. It's a negative square root of 33. And then add a positive 3 to that. Divide by 2. Tenths, hundredths, thousandths. 2 says leave it alone. So I'll have negative 1.372. And there you go. Those are the x-intercepts. If you were asked to put that in an ordered pair form, right, that's the x value. So one would be 4.3720, right? The y value is 0 because it's an intercept. The other one would be negative 1.3720. Those are the two x-intercepts of that quadratic equation.